Good morning, good afternoon. This is 4.1 Representing Relationships, Day 1. We are going to be describing a relationship using words, being able to write an equation for linear relationships, and using equations to solve problems. Tomorrow we'll be creating a table of values and graphing. So here we have a set of data involving independent and dependent variables. It's going to be a linear relationship. Remember, this is going to be your x and this is going to be your y. Variables that have a straight line for a graph. Okay, it can be represented by using words, equation, and this might be easier. Words, equations, tables, and graphs. Today we're going to be concentrating on the words and the equations, and then tomorrow we'll be talking about the tables and the graph, or day 2 will be. Equations don't have to use, this is an E, use X and Y. You can use, say, H for hot dog, or if you're talking about the cost, you can use C. You don't necessarily have to use X and Y. For the words, you want to use words such as per and each. Okay? So let's go to one of our first examples. The table shows the number of liters in quarts of liquid. Write an equation to find the number of liters in any number of quarts. So if you look here, we have, if we did 0.95, or remember, if I have a table, first one's your x, second one's your y. So if I do y divided by x, and they're all the same, that means it's going to show direct variation. So if I do 0.95 divided by 1, I get 0.95. If I do 1.9 divided by 2 and 2.85 divided by 3, if I went and did 3.8 divided by 4 and 4.75 divided by 5, I would get this point, or 95 hundredths. So this is going to equal my m, because y equals mx is my direct variation equation. So instead of m, I'm going to write 0.95x. Now I want to write an equation using the variables that they give me. So instead of x, I'm going to put q, so 0.95q, and it equals, instead of y, I'm going to put L. So I'll put L this way. L equals 0.95 quarts. So describe it using words. So we want to use each or per. So let me see if I can get this. This will be easier, so I don't have to write it all down. Here we go. Each quart is 0.95 liters, or there is 0.95 liters per quart. Okay, and then if we are going to, about how many liters are in 8 quarts, I'm going to take this equation that I've written, or I have, and I'm asking how many are 8 quarts. So instead of this q, I'm going to put 8. So 0.95 times 8, and that's going to equal, what did we say on that other one? 7.6, and I want to make sure to label it, so 7.6 liters. Okay, our next equation, the total cost of tickets at a school play is shown on the table. Again, if I were to do, label this one x and y, I want to do y divided by x, and if they are all the same, then it shows direct variation. So 450 divided by 1 is 450. Is that the same as 9 divided by 2 and 13 divided by 3? Do they equal? They do, they are all 4.5 or $4.50. So remember, this is my M. So with direct variation, we're going to replace the M with $4.50 X. But again, I want to write it using these variables. So instead of X, I'm going to write T. And instead of the Y, I'm going to write C. So C is the total cost. It equals $4.50 per T or ticket. So using words, I want to write that. So it's, again, I can just write it. I can pull this one up and you can copy it from here. Each ticket, so using the word each ticket costs $4.50, or the cost is $4.50 per ticket. Okay? Again, using the equation, find the cost of 15 tickets. I'm going to replace 15 with the tickets. So C equals $4.50. Instead of that T, I'm going to write 15. And I want to 67.50. C equals, or the cost is equal to $67.50. And here my labels, enough is the $sign. Okay, now looking at from a graph, the total distance Marlin ran in 1 week is shown. Write an equation to find the number of miles, Y, so the total number of miles, after any number of days, and that number of days is on the bottom, or X. So again, we're going to check if 17.5 divided by 5 is equal to 14 divided by 4, 10.5 divided by 3, 7 divided by 2, and 7, or these, remember these are X and Y's, they're all X and Y's. So 7 divided by 2, is that the same as 10.5 divided by 3? And it is. They're all 3.5. So I'm going to write Y equals 3.5x. I'm going to leave them as X and Y because that's the variables they give me. But here's my equation. And then how many miles would Marlin run after 2 weeks? Well, we're talking about in days. So first we need to figure out how many days are in 2 weeks. So I'm going to multiply it by 7 to get 14. And then I'm going to take my equation and whatever is representing the days, which is my X, I'm going to replace with 14. 3.5 times 14, so Y equals 49. And what is it? It's miles. Okay. Our last one is going to be the number of trees saved by recycling paper. Oh, sorry. We have to use words. So our words, how we would describe this, is each day, so using the word each day Marlin runs 3.5 miles, or I could say Marlin runs 3.5 miles per day. Okay. Last one, the number of trees saved by recycling paper is shown. Write an equation. So if I check 34 divided by 2, or my Y divided by my X, and 51 divided by 3, does it all equal the same thing? I would want to check each one of these, and they do equal 17. So it's going to be Y equals 17x. And using words, if I recycle if I recycle 1 ton, remember because this is my X and this is my Y, 1 is the X and that's the ton of paper. So 1 ton of paper, I will have saved 17, whatever the Y is, and the Y is the trees saved. So I will have saved 17 trees. So each ton of paper recycled saves 17 trees, or 17 trees are saved per ton of paper. And then I can go in and take my equation here and replace X with my 500 tons. So use the equation to find how many trees can be saved if 500 tons of paper are recycled. I would do my math, 17 times 500, and I would get 8,500. And I need to remember to label trees. All right. That's the end of day 1. Your assignment should be on the board.